Welcome, everyone. So in this video, we're going to go ahead and talk about Avogadro's law, which relates the mole and the volume of gases. So Avogadro's law tells us that equal volumes of gases at the same temperature and pressure will contain the same number of particles. So if I have 10 particles over here and 10 particles over here, they will take up the same amount of space. So let's go ahead. The graph of this is a nice straight line, just like we've had with Charles's law and also with Gay-Lussig's law. So we have that nice linear relationship between volume and moles. So as the number of moles increases, the volume also increases and vice versa. So as the number of moles decreases, the volume will also decrease. The equation for Avogadro's law is V1 over N1 equals V2 over N2. Remember, 1 stand for the initial set of values, 2's stand for the final set of values. V is the volume, and N stands for the number of moles. Remember, is Avogadro's number 6.02 times 10 to the 23rd things. So in this case, we're generally be talking about molecules and also atoms, but we could use the mole to describe anything. So for a real life example is inflating a basketball. As you inflate a basketball, you're adding more air, so molecules of oxygen, nitrogen, hydrogen, anything else that's in the air. And as the number of the gas particles increases, the volume of the basketball increases. For a real life example from the lab that we watched, when they were inflating the balloons, they were adding more air to them, just like in the basketball. So again, the balloons expanded. So let's go ahead and try out some mathematical examples using Avogadro's law. Okay, so let's go ahead and try some examples of Avogadro's law. So as a reminder, the equation for Avogadro's law is V1 over N1 equals V2 over N2, where V is the volume and N is the number of moles. Okay, so for our first example, a large beach ball has a volume of 4.60 liters when it is filled with 0.225 moles of air. If air leaks out, so the volume decreases to 3.60 liters, how many moles of gas escaped? Okay, so we have our volume and we have our number of moles. And those two values are paired together. They're talking about the initial set of conditions before the air escapes. So we're going to make those our 1. So our V1 is equal to 4.60 liters. Our N1 is equal to 0.225 moles. And then we're told that air leaks out, so the volume then decreases to 3.60 liters. That's going to be our V2. And for our N2, we are being asked how many moles of gas escaped. Okay, so we do not know N2, which is the amount of moles in our beach ball, but we can figure that out. And then once we know that value, then we can figure out how much gas escaped. Okay, so it's going to be a 2-step problem for us. So let's go ahead and start by plugging in our values to our equation. So we have 4.60 liters, that's our initial volume, divided by 0.225 moles. Okay, so those are the initial values. And that is going to be equal to our final volume, which is 3.60 liters, divided by our N2, which is our unknown. Okay, so we're going to go ahead and cross multiply and then divide to get the N2 by itself. So we're going to have 4.60 liters times N2 is equal to 3.60 liters times the number of initial moles, 0.225. And then we're going to divide both sides by that 4.60 to get the N2 by itself. Okay, so this is going to cancel out, leaving us with just the N2. And then if we look on the product side, the liters cancel out, which leaves us with just the plain old moles. So let's go ahead and we're going to plug this into our calculator. So we have 3.6 times 0.225, and that's divided by 4.6. So N2 is equal to this number, and we want to think about the number of moles. In each case, we have 3 sig figs. This one, remember, leading zeros never count, so that's still just 3 sig figs. Trailing zeros do count because we have decimal points in this case. So the number of moles in our balloon after the air escapes is 0.17 moles, and that's the air in the balloon. Okay, now this is not asking how many moles of air are left in my balloon. This is asking how many moles of gas escaped. Well, we know how much we started with. We know how much we're left with. We can find out how much escaped by subtracting the two values. So 0.225 minus 0.176 moles. Okay, so that's the initial, that's the final. If we subtract those two, that will tell us how much escaped. So 0.225 minus 0.176 gives me a value of 0.049 moles escaped. Okay, and for sig figs, we are perfectly okay here because when we subtract, we go to the least accurate place value. So we're going to have it to 3 place values plus past the decimal point. So that is the answer for the first one. So 0.049 moles of air escaped, which left 0.176 moles in our balloon. Okay, so for the U-try, I want you to go ahead, try this one on your own. A 4.8 liter sample of helium gas contains 0.22 moles of helium. How many additional moles of helium gas must be added to the sample to obtain a volume of 6.4 liters? Okay, so go ahead, pause this video, try it on your own, and then come back and we'll talk about it. Okay, so as we read through this, we see that we have our initial paired values, that our volume is equal to 4.8 liters initially, that's our V1, and our N1 is equal to 0.22 moles. Okay, our V2, our final volume, is going to be 6.4 liters. We need to start by finding our N2, so how many moles are in that final balloon. And then we're going to do a little bit of math to find out how much we added. Okay, so if we go ahead and set up our equation, we have 4.8 liters divided by 0.22 moles is equal to 6.4 liters divided by N2. And again, we're going to cross multiply and divide to get the N2 by itself. So we have 4.8 liters times N2 is equal to 6.4 liters times 0.22 moles. And then we're going to divide both sides by the 4.8 liters to get the N2 by itself. Okay, so we go ahead and plug this into our calculator. 6.4 times 0.22 divided by 4.8. So that gives us an N2 equal to 0.29 moles. And I'm going to have 2 sig figs in this case because that's what all of my given values have. So this is how many moles of air are in the balloon when it has a volume of 6.4. But I'm being asked how much gas must be added. Okay, so not how much is in the final balloon, but how much is added. So I know the final. I know what I started with. I can find out how much I add by subtracting the two. So 0.29 minus the initial value, 0.22. So this tells me 0.07 moles was added. Okay, so I hope this helps. If you have any questions on Avogadro's law, please feel free to let me know. Otherwise, have a great day, everyone. Bye.